I'd very much like for this video to talk for me, but I can't figure out how to get it to play over the speakers in here. And I was goofing around with it earlier, still couldn't get it to work. So we'll get the Erica version, and you can see it has words down here too. But interferon, always think viruses, right? So this is antiviral. And as the name of the cytokine, right, this chemical signal implies, it interferes with viruses, right? So the first thing that's got to happen is a virus has got to go into a cell, right? So virus attaches, actually, first thing, right? Gains entry into the cell, right? Then it uncoats, and it's going to use its nucleic acid to make copies of its own nucleic acid and to make its proteins. Well, in our cells, that'll sometimes trigger, right? Because we can sense that a virus got in. It'll trigger the production of interferon, right? And that's what this molecule is. What interferon does is it goes to neighboring cells and binds to the surface of those cells. Okay? So there it goes, binds to that cell. It's a signal to that cell, basically saying, hey, a virus is here, get ready, because look, what might be coming your way? A virus. Okay? But they've been prepared by interferon, right? So even though the virus gets into the cell, they know it's coming, right? So if you know a bad guy's coming, what are you going to do?
Kill yourself.
I'm going to call the police. Or someone with a gun. I don't know. Right? You're going to get prepared, right? You're going to get prepared. But you know what? He's trying to be funny, but he's kind of right, too, in the same aspect. Because guess what happens, right? So this cell gets prepared. And the way that it gets prepared is it produces enzymes that will destroy messenger RNA. Even its own messenger RNA. But in doing that, what is it going to stop the virus from doing? Replicating in that cell, right? So this cell, yes, is going to commit suicide, right? So the viral, right, RNA is going to get destroyed. So does the cells, right? This cell goes through the process of programmed cell death that we call apoptosis. The good news is we're multicellular organisms, right? We've got cells to spare. We can't spare, too many in certain types, right? It's not a good idea to sacrifice them. But this is also why sometimes when you see on TV and they talk about certain antivirals and they'll say it doesn't include interferon, because we produce interferon. But of course, some viruses, the reason why they're able to still replicate is they're able to stop this mechanism, right? They shut down our own production of interferon. So for some viruses, part of the treatment that they give people is to literally give them interferon, because that virus that they have shuts down this pathway. So we give you your own cytokine, right? Your own chemical signal so that your cells get ready. So if the virus does get in, right, they'll destroy it and stop the replication cycle. So this is a diagram from your book, right? So what does interferon do, right? As we saw in the video, it's going to degrade RNAs, right? Which prevents the virus from making its protein coat. It'll inhibit the ribosomes from binding to the messenger RNA, again, stopping the virus from making its protein coat. This will often trigger in that cell that this is happening in what we call programmed cell death, which is apoptosis. And the important thing about apoptosis is it does not elicit inflammation, right? So this is, quiet death, right? We're not going to call in reinforcements. The cell's going to die. Sometimes interferon will change the membrane proteins, and that'll actually even stop the virus from getting into the cell. And in that case, the cell is safe, right? The good news is all of this leads to the prevention of viral replication in that cell, right? So we stop the viral cycle. And that's what's really important about interferon. So since this is still part 3, helps if I can hit the